Next, may we invite Dr. Katherine Kwan, Product Development and Management Vice President, Consumer Group of PCCW, to share with us how ISP in Hong Kong get ready for IPv6. Katherine, please.
Hello, good afternoon, ladies and gentlemen. Thanks for the opportunity to speak here and to speak on behalf of a service provider in Hong Kong. Speaking on behalf of PCCW today, I must say that IPv6, and we want it very bad. There are a lot of limitations that we have to address, and we just want to test it properly. It just takes time. Back more than 10 years ago, when I was an engineer planning for 3G network, I was told by vendors that in the future, every appliances at home will be IP connected. Cars will be IP connected as well, and everybody will be carrying mobile phones and other smart devices that got connected to the internet. So over the 10 years, we rolled out very high-speed broadband networks. We rolled out 3G networks, which get faster and faster data speeds. But then we suddenly realized that we've gotten a problem. We're running out of IP addresses, IPv4 addresses. So that's why we're here today. I don't think this is a venue to educate the benefits of IPv6. But the point that I want to address is that without IPv6, we won't be able to provide more innovative services that can look beyond to the consumer devices. That is going to change the way how applications work. And also, it's going to provide more efficient routing behavior and more QoS and mobility support to these IP-connected services. To us, the migration from IPv4 to V6 is not going to be an option. And because of those two protocols are not compatible, this is going to exist for a while together. There are three main implementation approaches, mainly dual stack, tunneling, and translation. Each of these methods has got its pros and cons, and we believe that the dual stack approach is more preferred. It's just because it's going to support the coexisting of IPv4 and IPv6 internet for a while. But the bad thing is that we still need IPv4 addresses. And we need to provide extra resources to run V6 over existing V4 infrastructure. The second method is tunneling. It is fast, and we don't need to upgrade the whole infrastructure to support IPv6. But the bad thing is that still we need IPv4 addresses, and it's not going to pave way for V6 migration. The last method is translation. This method works on V6 only infrastructure, and we can use this method to provision for V6 customers, which can solve the problem of the lack of V4 addresses for this moment. Bad thing is that translation technology is not that mature. So to PCCW, we believe that these workaround approaches are only going to delay the problems by some months, but the issue of running out of V4 addresses is going to remain, and migration is necessary. It is important for us to pave way for V6 as the leading local ISP and major international carrier. I must say, PCCW is a quadruple play service provider. We are just not a telco who lives on copper wires only. We are rolling out fiber network. We provide contents. We are an international carrier, and we are running a lot of other services. So we are seeing that if there are other players who are not ready to get V6 support by the end of this year or next year, they are going to suffer. So to us, while we are investing heavily on upgrading our network infrastructure to support fiber broadband services, to be able to provide the state-of-the-art next-generation internet technology is important. Challenges that we are meeting is that there are still large amount of legacy nodes and CPE outside. and it's going to be there for a long time. How are we going to manage these V4 resources over the transition period? And also, end-user applications and external contents are not yet V6 ready. For us, we still have to find budgets to justify this migration. It's not going to generate new revenue, but it is about service continuity, and it's mandatory, and it is about revenue protection. So for us, it's a must-do. In terms of the very big consumer services network out there, there is a large amount of CPE that still has to be migrated or upgraded to support V6. The good news is that we see a lot of efforts from the industry. For example, the Broadband Forum and the IPv6 Forum has developed a pact to drive the adaptation of IPv6 in broadband networks. And then they have developed a suite of specifications for vendors to follow so that the DSL or fiber to the home technology can be migrating to support V6 based on this set of specifications. This current set of specifications aims to handle the ongoing surge of new user devices, such as tablets, smartphones, home gateways, and other appliances at home. In the future, they will also include specs to support the ability to support secure mobile and nomadic applications, as well as machine-to-machine communications. And as the other speakers has mentioned earlier, our concerns is not about equipment support or equipment compliance. There is also security issues. When you migrate or when you're supporting translation, there will be security vulnerabilities. And also, the large subnet blocks on IPv6 takes a lot of more efforts for monitoring and management. It takes a very long time for subnet to be scanned for security impacts. And also, there are a lot of powerful features enabled on V6. So there must be new ways or know-hows to manage these powerful features. Otherwise, they will be open up new opportunities for hackers to attack, such as the neighbor discovery and solicitation features on IPv6, which could be leveraged by the hackers to perform spoofing-like actions. And also, IPv6 provide long extension hackers, which could provide a mean for overwhelming firewalls and security gateways. And lastly, the 4 to 6 IPv6 proxy servers may allow proxy operators to be leveraged as the sources of attacks. So these are only some of the potentials for security loopholes that exist when we are considering migrating from V4 to V6. And to us, our approach of providing support to V6 is going to be a phase-by-phase approach. We are going to provide initial deployment for broadband internet and VPN services, but not yet with the walled garden content services like our iMultimedia services or the IPTV services for consumers. And as I've said, the dual stack approach will be preferred for internet services. And also gradually, we will also migrate the company and websites and service portals to support IPv6. Just look at our international carrier business. PCCW Globals. Last year, they have already upgraded their infrastructure to support IPv6. PCCW Global is today providing international carrier service to more than 1,500 cities over 110 countries with integrated solutions based on the latest IP and fiber network technologies. Last year, in August, PCCW Global has already announced the support on IPv6 through the enhancement of its dual stack solution for the IP transit and global internet access services. We have allowed customers to run internet traffic based on both V4 and V6 standards on a seamless fashion via a single connection. The upgrade for these services is mainly based on the MPLS core with V4 capsulate function and to the edge routers. We have already upgraded our website to support both IPv4 and IPv6. So you can take a look at www.pcwglobal.com. The other services that we have already been upgraded to support V6 is a Metro IP service for business customers. We have done it through the implementation of dual stack support. It took us about 6 months for the planning and implementation. Step one, we spend a lot of time to ensure the compatibility of V6 protocols for the different network elements, and we tested through every single piece of equipment so that they are compliant. And then we plan to implement software upgrade on the network from the access network to internet gateways. As well as we obtain the IPv6 address from APNet. And then the consideration of how we start and which part of the network is being upgraded is being justified by the cost and technical or economic feasibility. So we started from the backbone, core equipment, provider edge equipment, and the access network down to the CPE side. Apart from the core equipment, we also have to set up the peering links with the upstream and HKIX. Step 3, we still have to plan the infrastructure such as DNS and then to test the other monitoring tools as well. DNS service has been upgraded with both V4 and V6 addresses. And also, there are also LDAP and Radius and other authentication system that has to be upgraded to support V6. And lastly, there are other supporting system that we have to consider in order to make this an end-to-end ready service. So we have already launched this Metro IP service to our business customers, and today we have customers using this service already. So we are already V6 ready. With the consumer broadband services, it is a much more tedious exercise because we are actually serving the majority of the Hong Kong residential customers. We are offering a good variety of technology and internet speed through the different mix of technology. If you look at it vertically from the speed aspect, we have DSL technology and fiber technology to offer a speed from as low as like 6 meg to 1,000 meg using fiber direct technology. At the same time, we believe that broadband is not going to be limited to a fixed location at home, and that's why we have wireless technology to complement the service. And we consider this as an ubiquitous broadband coverage. So to us, the consumer broadband internet service is about a fixed network service to your home, as well as a mixture of Wi-Fi and mobile network services. Those who are in Hong Kong, you must know the current campaign that we are running. We are actually aggressively rolling out high-speed fiber broadband services to the mass. So this kind of very advanced V6 supported services is not going to be limited to certain households, nor is it going to be an expensive services for those who can afford, but it is going to be for the mass. It is going to cover the majority of the customers in the residential segment. And we are going to be very aggressively to upgrade the existing service to our customers. About the roadmap, with the fiber network services, because it's a new service, and we are pushing IPv6 support eagerly. So most of the equipment are already upgraded from the core network and from the edge router side. They will be ready by the end of this year. It's going to take a little bit more time for some of the, maybe for the authentication service platforms, for the BRAS, that's going to take some time, but we hope that it's going to be ready by Q4 this year. And whereas for the DSL services, because it takes more time for the CPE equipment to be compliant to V6, it's going to take more time. But we'll still hope that it's going to be to start to support V6 next year. As I've said, our broadband services is not just about a fixed broadband service. We have wireless service to complement this. And for wireless services, again, there are a lot of mobility issues and a lot of CPU issues that we have to tackle, and also roaming issues. And we are going to take a little bit more time to test it through and to plan out properly. And we target this to be ready next year. Lastly, on our websites, we have just turned on IPv6 support on the Navigator website. You can try visiting the Navigator website. And the first one, IPv6.navigator.com, is a IPv6 access-only website. Whereas for the second, www.navigator.com supports both V4 and V6, is still stack supported. Also, PCCW Global has its V6 supported website as well. And then lastly, I would like to show you a demo of our residential broadband service that runs IPv6. This is a 100 meg fiber line from our production platform. You can see that I'm using a Windows PC with V6 configured to access our Navigator website. It shows that it's running V6, right? This is a website that runs a compliance test on the network to see whether the ISP is fully compliant to V4 and V6. And we got full marks on this test. Then we run a speed test. Even the speed tester has to be supporting IPv6. So we get a download speed of 670 meg. The line is supposed to be 1,000 meg, but there are limitations on Windows, so it's not the actual speed. Okay, fair enough, 400 upload speed. Next, I try to go to other V6 website. Let's try the Google site. And it works. Right. So from this demo, you can see that we are already running successful trials for the consumer broadband service for V6 support. And there are lots of other considerations. For example, speed testers, other supporting systems that we have to consider to make it work end-to-end. And we are really eager to make IPv6 support, and we are here just to seek everybody's support from the industry, such as equipment vendors and content providers, to work on making IPv6 work. Thank you very much.
Thank you, Dr. Kwan. Last but not least, Warren Kwok, Telecom engineer of OFTA, will tell us the experience of deploying IPv6 in the Office of the Telecommunications Authority. Warren, please.
Hello, everybody. Over the last two sections, the guest speaker asked question, are you ready? I'm proud to say in this session that we are ready. Nothing is going to stop us from deploying IPv6. Over time, we'll do better and better. And by the way, my name is Warren Kwok, a telecom engineer from OFTA. So, everything has a beginning. How do we move to IPv6? We develop our own transition plan. For stage one, we use a tunneling approach to enable our website on IPv6. Later on, we have a native IPv6 connection. Then we move our website web server to native IPv6 together with firewall protection. Our next stage is to enable DOSNet in our SMTP server. This is a very, very difficult task. I'll tell you later on. And stage 4, after scrapping all the Windows XP machine, we will have Windows 7. By that time, all our internal system, internal hosts, will be DOSNet. And by the way, we can go native at the first stage, but at that time, there was only one service provider that can offer IPv6 connectivity. As a telecom regulator, we like to promote competition, so we cannot allow ourselves to purchase service from a single service provider. For the interim V6 web server, we have conducted some study about what kinds of tunnel would be best. We study about 6-in-4 and 6-to-4 tunnel. Both of them are available from Hurricane Electric and free of charge to us. The bandwidth, quite large, 1 gigabit. For 6-in-4 tunnel, it is a manual configured tunnel. And there must be an account name and password. And after log on, you have to configure, you have to tell the service provider your endpoint. On your side, you have to configure the endpoint. So there is a need to have a startup script to fire up the tunnel. For 6-to-4, it is totally automatic. It is always on, no startup script is required. So if I ask you, you have the choice, 6-in-4 tunnel, 6-to-4 tunnel, what will you choose? Anyone choose 6-in-4? Anyone choose 6-to-4? Nobody. I think. So we have chosen a 6-to-4 tunnel, and we set aside a new server to serve our V6 website. For 6-to-4 tunnel, there is a security risk in the address format since we are using Windows system. If we look at the mapped address, the 3rd to 6 octets are exactly identical to the 13 and 16 octet. So this is a very important message to a hacker. You are using Windows system. I can hack you. So what we do now, we change the 13 to 16 octet to some arbitrary hexadecimal figure. So that helps to hide our identity. I must say that the IP address given in this slide are not our IP address. I have to protect our network. So they are for illustration only. Later on, when we look at the web server node, we notice that the traffic for the V6 traffic was quite low. And we found out that if a website has both native v4 and 624 tunnel, all DLStat hosts in the world try to CNAP the native v4 path. So how about the visitors to our V6 website? They will Windows 7 machine with 624 tunnel enabled. So that is to say, 624 server and 624 hosts are on the same network. So they have a higher priority than native IPv4. So we still have quite a small traffic. So at this point, we realized that we made a mistake. We should have used 6-in-4. 6-in-4 tunnels are treated as native by all DLStat hosts in the world. But we don't want to change because we will be moving to native connection very soon. This is a very painful learning exercise. If you intend to do IPv6 web server by tunnel, by all means, use 6-in-4. If you use 6-to-4, I don't call you my friend. So let us look at our V6 traffic in the server log. If we look at the 3rd to 6th octet and compare with the 13 to 16 octet, you will notice that they are Windows 7 machine with multiple IP address, and they activate a 6-to-4 tunnel. Of course, there are some native IPv6 hosts to our website, but the number is quite small. So after gaining some experience, we decided to move to native IPv6 connection. When we decided to move to native, we know that there are more than one service provider, so we will not be criticized by other players. So we like to begin with something very small. So the bandwidth is just 2 meg. 2 meg is very small. The availability, 99.9%. This is also a not very good service. And for the forward lookup service, this is optional because our v4 ISP is doing this for us. However, for the V6 address reverse lookup, the serving ISP must do this part because we will have our V6 SMTP server. Reverse lookup is a standard feature, mandatory feature for SMTP. If the ISP do not handle this part, we will not be able to send out V6 email. And for firewall, there is no need for the service provider to provide this kind of equipment. We have very good technical knowledge on V6 firewall. I repeat again, we have very good technical knowledge on V6 firewall. This table compares our V4 and V6 provision. Actually, the DLStat name, the V6 name is a DLStat connection, but the V4 address are no use to us. If you want to use the V4 address, I can give it to you. As you can see, even the bandwidth is just 2 megabits per second. The service charge is much higher than a V4 link with 100 megabits per second. This is a question of what? Supply and demand, right? Right now, a lot of organizations want IPv6 native connection, but there are just few ISP willing to provide the service. I hope over time, more ISP can provide service, give us a choice. So on our V6 network, we face a difficult problem of enabling DLStat in the SMTP server. Our V4 SMTP server is closely integrated with an anti-spam software, but that software cannot support IPv6. What we can do now is to set aside a dedicated V6 SMTP server to receive incoming V6 email. And by means of a dedicated network interface, we pass the V6 incoming email to the V4 mail server platform with anti-spam. We will move to dual-stack SMTP server by next year when the anti-spam engine can fully support dual-stack. So you may ask, what do we think about V6 firewall? I can tell you that V6 firewall are mature, widely available, and quite affordable to small business. And some people still put forward the argument that I don't want to do IPv6 because I have no confidence in the firewall. If no firewall means nothing, my network is not protected. And I also like to stress that in configuring V6 firewall, special attention must be paid to the proper filtering of ICMP V6 message. For example, packet too big. In IPv6, router will not do fragmentation. Only the source and the destination, we have to talk to each other. The packet size is too big, and I send you the signal that packet too big, you try to reduce the packet size. And another example is the destination unreachable. In case of a dual-stack server, and if the V6 path is unavailable, then there's a need for the host to fall back to V4. The destination host unreachable is the proper message. And I also like to say that in V6 firewall, you have to enable the passage of our UDP packet larger than 512 bytes for DNS traffic. If you ask for name server information of .com, you will receive 13 answers, 13 V4 address, 13 V6 address. That packet will, the size of that packet will exceed 512 bytes. And lastly, people cannot just copy and paste V4 firewall rules without analyzing if this rule set can still be applicable in a V6 network environment. So be careful. Don't just copy and paste. So this is a scriptum of our test about brokenness on IPv6 for our V4 network. Since we have killed all the potential V6 tunnel in our V4 network, we will not have any problem of brokenness. And on the World IPv6 Day, that's June, 8th of June today, we will continue to access Facebook, Google, and Yahoo with the existing V4 path. This is our test on the V6 network. Unfortunately, we failed the test in a very minor manner. The reason is that the serving ISP does not provide us with a V6 DNS resolver system. The IP address of the two sets of DNS are V6 address. I tell you why. Actually, the DNS allocated to the clients are just cache server. They have a V6 address. But this cache server are connected to forwarder, but the forwarder cannot support dual-stack. So that is a problem. This problem may affect our global IPv6 reachability in future. We have alerted our serving ISP about this problem. And we do not consider this as a never thought at this moment. But be careful. Our next tender will be 2 years. If you cannot provide full dual-stack on the resolving system, you fail our technical requirement, and you will not get our business. So by now, we have a native IPv6 network. What can we do next? We can set aside a SNAS 64 network for testing. and another /64 network for training. This kind of flexibility can never happen in corporate V4 network. In V6 network, I have a big subnet for testing, for training. Are you jealous? Yes, you are. And we might consider a higher bandwidth dual stacking in order to serve our separate V4 and V6 network in order to save costs. And in the meantime, we will monitor the development and availability of a high-end V6 system, like load balancer, packet saver, bandwidth manager, IDS, IPS. If these equipment are widely available and affordable, we will install some of them. We do have a wish list for 2011. Right now in Hong Kong, we do not have an authoritative V6 NTP server. Thanks to Chihu, CUHK released the NTP server for the whole community. And I have a good news for you. By the end of this year, the Hong Kong Observatory will offer oneself an authoritative V6 server. On service side, we hope that more ISP can provide V6 connection and they can lower the service charge. We also hope that they can offer advice to clients, small business about tunneling approach, and they can give regular briefing to customer about IPv6 adoption and the importance. And the last speaker, I was impressed by the last speaker. Their website has a IPv6 ISP logo. That logo is very difficult to get. So I encourage ISP to get that ISP certified logo. With that logo, customer can have huge confidence on your V6 capability, and you don't need to advertise. That logo will help you. This is my last slide. You can see that on our website we have the IPv6 World Wide Web certified logo. I appeal to all domains, all website owners to do the same. By having this logo in your website, you are helping to drive the public awareness and further promote the IPv6 adoption in the community. So that's come to the end of my presentation, and I'm happy to answer questions in the panel discussion section. Thank you.